Yeah. So I think it might be like, yeah, I think like, yeah, try this, try to see what happens. I can just, I'll paste the command on Zoom. So try first echoing your GFLib path, and sorry, not echo. I mean like ls. See what is there. So just like. Okay.
Once it completes. Hold on a sec. Why is my Zoom not coming up? ls GFLib path all tenses. Oh, well, I don't have GFLib path set. I wonder why. I thought, oh, it's because this is a new machine.
Okay.
Sorry. Why was it working over there before? Okay. Okay, so I need to set GFLib path to this.
Yeah.
Okay, so that's my GFLib path. Okay, now I don't have anything. Okay, so I'm looking for dict-ing, and why am I not finding it?
Okay, so I gave you another. So okay, so it seems that it doesn't put automatically a dict-eng there. So you need to go to the source file with the English and.
Here?
Yeah, and then src/English. Yeah, and then paste that.
I would have expected that to be built by the stack install.
Yeah, me too. Let's open an issue.
Maybe it was because I didn't have GFLib path installed.
No. I think it's like, yeah, I think it's an issue. Like we need to fix it. I think like it's by default because like this dict is an English specific thing, so it's not part of the core modules because it's just a monolingual lexicon. So. Okay.
Okay, it's working.
Yeah. Okay.
Yay.
Cool.
Look at that. So all this is working. Okay. So this is from what I'm seeing here, these are the deontic expressions that basically say this party must, may, must not do some action, right?
Oh, yeah, there is even not negation. There's just must and may, and right. I think there should be and should. Yeah.
Okay, well, we could do a couple of things in the next couple hours. We could add negation so that we have must not. We have prohibition. We could try to connect this up using PGF to a Haskell sort of source upstream. We could extend the grammar to add conditions. We could extend the grammar to add defeasibility. We could extend the grammar to add temporal deadlines. According to my theory, the underlying structure for a clause is something like the structure that they all have in common is something like this. It's if an event occurs during this state, then this party must perform this action before this deadline. All right, so that's kind of the skeletal core of the sentence. And if we could extend our grammar to say this, do you think that's something we can achieve? What do you think? If an event occurs, then the party must do this thing before this deadline.
Yeah, that's possible. Like, I think that's pretty, yeah, that should be pretty straightforward. Like, because these are like just phrases, so we can just put like, we need to change the link at a bit, but like I think that should be very, very easy.
Okay. And would it also be feasible to try to do what was documented in your blog post, to do a PGF integration?
All of that in 2 hours, I'm a bit skeptical, but like,
no. Okay, because I'm wondering if you have this PGF stuff planned for later in the week, or?
I mean, I did a bit of it last week, actually. So.
Okay.
So no, haven't planned for this week.
Okay. Well, what would everybody in the room like to do? Should we try for a very simple PGF integration? Should we try extending the grammar? What would everybody prefer? Want a show of hands for do a PGF integration for the comploting? 1, 2, 3, 4. And who would like to extend the grammar? 1. And who doesn't believe in the law of the excluded middle? We are all constructivists here, I see. All right, so what do you think we should do? Inari, you decide.
Oh. We can start from the PGF, and then if we have time, we can extend the grammar.
Okay.
Actually, what I showed was the PGF integration on Python, so we haven't shown it on Haskell.
Okay, well, let's do a little PGF integration in Haskell then.
Yeah.
All right, so just for the reference, of all the people who are dialing in, we are going to look at Inari's blog that talks about how to embed these things. I remember watching you write this blog post in Madrid, I think.
Yes, that's correct. You were like my first beta reader. Like,
that's right.
And then you said it's very confusing because it jumps around, and then I just kept it as it is.
That's right. So I remember we were hanging out in Madrid. December 12th was Jurix, the International Conference on Legal Knowledge and Information Systems. And that was when Inari wrote this blog post. So, okay, so how do we begin? Shall I just write a very simple Haskell program that has very simple types, and then we will find a mapping from these types to the GF?
Yeah, sounds good.
Okay.
So yeah, that's the corpus, that's the semantics we have. So
perfect. Shall I jump into day 6 then?
Yeah. We can just we don't need to even duplicate the grammar. We can just copy the PGF and put it in day 6. So
yeah, is there? So how do I? Okay, as everybody can tell, I'm doing this for the first time also. So this is very exciting for me. Apologize if this is not a polished demonstration, but we're all getting to learn. Yeah. Is there a way I can get this thing to produce like Haskell?
Yes, there is. Yes. Okay, so let me type you on Zoom.
Okay.
So GF.
So while we do that, I'm going to go over to day 6. I'm going to stack view. See if this works.
So this produces both PGF and the Haskell. No, oh yeah, right, yes, sir.
Okay, so let's see what we've done here. We've produced complot.hs and we've produced complot.pgf. And this is in the separate lexicon directory. Over in the day 6 complot directory, we have produced a very basic set of Haskell thingies.
Yeah.
Okay, so this is your basic raw Haskell stack setup. And now let's go have a look at complot.hs. Okay, I need a second screen, so I'm just going to put the little chat window over here. A sec.
You can use those as a second screen as well, like those monitors here, Meng.
Oh yeah?
If you put like, don't display mirror, but extend screen, then you can put it there, but maybe it's a bit too small.
It's a little small for me to see.
Yes.
I might just have to do this, move to iPad.
Oh yeah, cool.
Ding.
Magic.
It almost worked. Oh no, I screwed up with the manager.
Oh.
Okay, cool. So that's over there. Let me just reset my displays. 1 sec. AirPlay display, sidecar display, Crestron. Oh, I may only be, okay, so I'm mirroring this with that. And this is over here. Okay. What's this? Okay, now I've mirrored everything. Okay, well, what I had in mind didn't work. Never mind. Okay, now everything is just mirrored. Oh, that was okay. Let's just go back here and keep trying. So let's have a look at the output of this. Wait, there should be something.hs now. Complot.hs at that. Perfect. And in here, what do we have?
So that's just a Haskell translation of the GF file. So like all of the cats are like data, and then the names of the functions are their constructors. Yeah, so like a simple case like kind, there you just have the lexicalized data breach, data leak, harm, organization. They are constructors for kind. And then for item, you have like a plural, the singular, and then the PDPC, and also a conj.
So let me find all this. This is in here. So this is we start with the abstract, right? Up here.
Yeah.
Okay, I see. So all of these things map to all of those things. So the deontic maps to that, modal action maps to that. Cool, and then the implementation is down here. Wow, this is so exciting. Okay.
Yeah, like this file is like nothing you really need to manipulate yourself. You just have like, you don't need to touch this file usually. Like,
okay,
it's auto-generated.
All right, so if I were to have this file in my stack program, I'd be able to just call it, right?
Mhm. Yeah.
Okay.
And you also need to have access to the PGF file. So
Okay, well, I'll
copy
just
both.
copy them over. Okay.
Yeah.
Let's see if that works.
You also need to import PGF. That's like.
Should I do a hiding tree?
Yeah, makes sense. Okay, so exciting. Will it will it build?
See if this works. Oh no. PDF. Okay, so I need to get PGF.
Yeah, you need to put stuff in.
YAML. Do I need it in stack? Maybe I do, maybe I don't. Let's see if I do. What version of PGF am I using? PGF 2. No, PGF. Awesome. So all of this should be fine, but don't I have to say in the package.yaml the version that I need for PGF? Okay. The version that I need is GF 3.10. Ah, okay. So this is what I was doing wrong.
No, actually, so we, yeah, right, yes.
GF 3.10.
Can you just?
It's the other thing that has the dash. Sorry. Equals. So I need to put this in my stack.yaml. Extra depths, extra depths. Okay. Oops. Okay, so while that's running, assuming that when that comes in, that should work. Here we've got the sort of concrete types. So if we were to generate, if we were to create a really simple type system, is the install coming? Oh no, not happy about. Am I too recent? What's my stack version?
a comment on that? Like, I'm wondering if you can you copy the stack file from one of the
8.10.4 should be fine, right?
ADL4?
Yeah. Why don't I check all this in?
It's like the stack file from my blog post is several years old.
Oh, okay.
And unfortunately, the GF that we have in stack package is still 3.10 because like we only did the binary for the release 3.11.
Okay, so what should I do here?
But I'm suggesting that if you go to baby L4, because we're doing the same thing on baby L4, so the stack file works there.
Okay.
Can we look at that?
Yeah.
Yeah. See what you need. So some extra depth here.
Okay, so I'll just move this over.
Yeah, obviously we don't need, like, there's a lot of things that are not GF related here. We don't need a GPUD, we don't need like.
The most important one is we are changing the resolver version from what, 18.5 to 16.20. Okay. So let's put that in there and see if it builds.
Yeah, I mean, remove all the LSP stuff and like the GFUD, and like you don't need, like, there's so much stuff you don't need. No dependent maps, no dependent sums, like pretty much like everything. Yeah. Yeah, remove the GFUD as well. Like there is just, 2 lines above, remove GFUD, and it's, yeah.
Think that'll work?
Try.
Right, for those dialing in, I apologize for all the grunge that we have to grind through here. If you're watching the recording, I hope you can skip to the point where we've got this actually working. But if you want to follow this at home, all of this will be checked into GitHub. So I'm gonna push it into GitHub now. All right, we'll let this grind. And let's go do the fun stuff. So the fun stuff is, let's create a very simple set of embedded DSL types. Okay, so let's have a L4 sentence, which is going to have a conditions. It's going to say, under these conditions, this party must or may perform some action. That action has certain parameters. And then there's a deadline. Does that make sense? So what we now need to do is have additional to define each one of these little things. So how are we going to represent conditional statements? We're just going to say if X is true. So let's have some kind of predicate condition. These conditions are now going to become a list of conditions, right? The condition is going to be some kind of predicate statement, which is going to be a good point. Let's have an event. Cool. Let's add events. So let's say the condition is going to be what Prolog calls a functor, but I think we should just call a condition term. A C state, C term. Let's just call it C pred. condition predicate is just going to be the thing to the left of the parens, and then we're going to have a bunch of things on the inside. Okay. Each one of these is just going to be a string because we love strings. Everything's a string. We're prototyping. That's fine. What this allows us to say is foo bar bas, where foo is a C pred, bar is a C term. Does that sound good? So we can do basically the same thing for an event. And that's all. Read. That's it. Equals plus, right? Show equal read equals some kind of act. Then equals string and params. So this that allows us to say pay maybe we want this to be map strings. Okay, that's a little bit more conventional. Pay to Bob some. Does that look good? We've got a basic like parameter kind of structure. It's a map for that. Lazy or strict? I really should go with strict, shouldn't I? Okay, so that gives us a syntax for doing like paying people money or notify Bob, body equals you owe me money. And then action params. Oh, we've taken care of action params because that's part of action now. And then deadline. We've only got one kind of deadline, which is going to be now. Then. Okay. Let's see, has this all compiled? Oh, look, we've got a GRC bug. The impossible has happened.
Oh.
How do I feel about this? While building setup.sh, HS.
Oh, right, that problem.
Oh, right, that problem.
The impossible has happened.
I've seen that.
Is it because I'm on the wrong chipset? x86 should be fine.
If I use a newer C version.
Sure. What should I do?
Update the resolver, I guess.
Resolver would you like me to use? It's all here, isn't it? Package. I was looking for the resolver versions. Sorry, where's the list of like resolver? Oh, sorry, stackage.org. Misheard you, sorry. There it is. Okay, what version shall we pick? 18.5. Really? Right there. Isn't that the one that I had trouble with previously? Okay. Okay, cool. Well, let's hope this works. Go ahead. 518.5, 518.5.
Yeah, I think there was the missing extra dots.
Okay, cool. All right, well, if this works, that'll be amazing. Let's go back to our language. Yeah, we're missing a party, aren't we? Yeah, now we've got a party. Good question. I think no, because each one of these clauses just talks about one party. But because I know that our GF grammar allows us to have multiple parties, let's just have multiple parties. Okay, so that's a party. Precious there. I'll just do this. Keeping it as simple as possible. Okay. Okay, well, there's our language. Let's read everything so it's nice while it builds. I wish there was a way to put this like deriving stuff off to one side. Is that what auto deriving is all about? Okay, well, anyway, here's our basic language. Any thoughts, comments, remarks? Does it sound good?
What is an event?
What is an event? It's upon a liquidity event.
Okay.
I like that.
Right. Okay. So in that case, so what the current GF grammar would only do the party, deontic, and action, and nothing more.
Okay, so we would need to add this one. We would need to add the current GF grammar has this, right?
Yeah, it has that. Do you want me to just like add the remaining stuff to the grammar? So, and should we work on parallel or like?
Yeah, sure. Why don't we work in parallel?
Okay. So,
Can you share your screen as well? So
Yeah.
we can share two screens at once.
okay.
And then
Sure.
people can just like dip in and out and they can watch you do your thing while they watch, or they can watch me fumble with my thing.
Well, so there's probably similarity to the definition of target automata.
Mhm.
It does, doesn't it? Because the timed automata would make use of this bit. It would make use of this bit, sort of preconditioned state, right? And it would make use of this bit, wouldn't it? So under these, when the automaton is in this state, when this event occurs, we have this sort of, this is the state transition. And then after that, that's your timing. So the logic of timed automata is really appropriate to representing contracts. In fact, there was a paper that came out not too long ago about contract as automaton. Now, this paper did not, if I recall correctly, did not represent it as a timed automaton, but it did represent it as an automaton. And the giant diagram looks like this. So good old graph is, good old dot file.
I'm gonna make a new repository for this. So I'm gonna put it on the day 6. Have you, do I need to pull anything or like, have you pushed anything? Or?
I'm gonna push right now.
Actually, no, I think I don't. I'll keep the day 5 grammar thesis and I'll just start from that in day 6.
Yeah, you can keep going in. Okay. Up to you. Let's see if this compiles. Oh no. Contain. Oh my God. Okay. I'm gonna check this in. Okay, everyone. So I have checked in the day 6 stuff. If anybody wants to go pull it, you're welcome to pull it and follow along. The specific commit point that we are at for anybody who's watching this recording is 5658 FEF. So if you're following us real time, you can pull just main head. But if you are replaying this class from a recording, you can get 5658 FEF.
Do you want to make a pull request so I get it to the
Oh, and then it should push right to the thing. Let's do that. Yep. 3 commits ahead, 2 commits behind. Now I should just be, why am I still 2 commits behind? I don't know.
Yeah.
Authentication. Does anybody else feel like they spend like half their day logging into things? Ta-da. Okay.
Yay. And I am merging it
So
now.
I've done a push. Should I do anything else?
No, that's good.
Okay,
I
cool.
merge it right now. So like,
So what I'm going
I'll-
to do now is write a very simple L4 sentence that more or less matches what you've got in your day 5 con. So let's do a very simple sentence that's supposed to represent, what's going to represent?
if you want to just like make it work already with the current PGF, you can put the missing things into lists, so it accepts an empty one.
I can put the missing things into lists.
Like I mean, in the like if you go up a bit in the Haskell file, like the L4 sentence, because there is no event and no deadline. Or okay, or of course you can just put like any random event there if you want to. Like if you want to look at the GF tree and then just like you can just make up an event and deadline while I'm typing them together.
Okay. So let's see. The what I'm looking to do here, whoops, hang on, sorry. So what I'm looking to do is create a, what's the top level sort of start cat here? Start cat is phrase, okay? Phrase. How to create a phrase? Okay, so we're trying to create a phrase of some sort, right? Okay, let's have an L4 sentence that says, for S, under some condition, which we don't have, in some event, always. We like these things, so we have very clear breakdowns. Some party, so let's say a party PDPC, right? Or what else do we have? Where do we have organization? So we just have some organization. List. Deontic. List. Action deadline. Action is going to be notify. Shall we call the action notify? So the action is going to be action notify. Then we just say affected individuals, or I think so. By some deadline. The deadline is going to be now. Okay, cool. So this ought to be a legal sentence. Okay, that didn't work. What did I do wrong? Go into the debugging. Perfect. Okay, cool. So we've got a very basic language going here that is able to say, always the party organization must notify affected individuals. Okay. Now, what we want to do is map this over and connect it using PGF. This is so exciting.
It's very exciting. Like I'm changing these things and like it's which one will make it faster. Like
Let's see.
oh no, I have to
We've
look
got-
into the art API. I don't remember it by heart.
We are racing to write some code here. Isn't this fun?
Yeah,
So
yeah.
L4 sentence
I'm having fun. I have
goes
to look
to it wants to be a phrase, doesn't it? Does it want to be a phrase? Well, so what I really need to do is instance L4 sentence into GF, right? And then a GF has type L4 sentence to expression. The expression is this the right way to go about it? Do I instantiate the L4 sentence into GF directly, or should I do it outside?
I mean, yeah, you can just construct the sentence in this directory, and then you can like because you have imported both the PGF library and the compla module, so you can do it in this file.
Okay, so I do this kind of approach, like an instance.
Oh yeah, that's perfect. Yeah, that's perfect.
Is that right? Okay.
Yeah, I think, yeah.
Okay, well, let's try it. So let's see.
So Mariam and Regina, you could help me.
Yes, who would like to advise me on this? Because now we are instantiating GFL4 sentence, and we need to produce an expression. And an expression. What's an expression? So do I want to? Wow.
We can start from a party, like, so like, you need to, like, if it's a party organization, you need to map it to the G organization, for instance.
Okay.
So like,
So let's just start simple. We'll instantiate that, right? Let's say GF, FG or GF?
yeah, I think it should actually be like, yeah, FG. Yeah, that makes sense, because
FG.
like GF is the one that makes it into like this raw PGF thing. And actually we probably don't need, yeah, we don't really need to care about that, because we can just, as soon as we get the G organization, then it does the magic. So
Okay, so is this right? Is that all I do?
I'm not sure. I mean, yeah, I've never made a type class out of it. I've just sort of have like I've like, is my mic open
You've
actually?
always just done strings, right? So that you've done like a different approach.
Yeah, like, I mean, I've also been using the TIDTs, so that's another different approach. But I mean, type class makes a whole lot of sense, like, so do that, yeah.
Okay.
Mhm.
Make CID. See that. Pause. Okay, struggle with this for a little bit, and then we should get something working in about half an hour at most. Make CID. This doesn't work. Parking X. String. Is it not a string? Is it a text?
Is this good? I posted something in the chat.
I see you've got something on the chat. Wow, you've got a whole bunch of things already. Okay, cool.
I mean, the only things I added, the only deadline I have is now, and the only event I have is always. I didn't push yet. I was just.
Okay, well, that's okay.
Is that?
That
Are
is
you
good.
happy with that? Do you want more stuff?
Do I want more stuff? Okay, so I'm looking at the chat. Chat says sprop always pred the SG kind, singular, the organization, modal action should notify PDPC now, right? The organization should always notify PDPC now. Okay, yeah, that's good. Let's use that, and then I'll try and convert my sentence to that.
Okay, perfect. So I will push, and I'll let you know when it's pushed.
Yeah.
You can pull.
Okay, so this is, I've created a very simple conversion function for party. So that turns into a GF expression. Once it's a GF expression, how do I turn it into a how do I turn it into a linearization? Create the updated PGF and Haskell files. Okay, let's do a pull. I've been told we can do a pull. Okay, I'm running the snippet that you told me to run. And we've got a new compl.pgf and a new compl.hs available. So that's cool. And now with that, I should be able to produce something. So once I've got this thing converted to the GF type, how do I linearize it? Okay. So we read the PGF file, then we use the PGF file to show, I guess, the linearization.
Yeah, yes, exactly. So we need to build an expression,
Okay.
and then we need to call the linearize function.
Right. So this is the expression, and then we show expression, right?
So actually, so to put the expression together, that's what you do that completely in the Haskell. So actually, now to think of it, maybe it's better that the type class that you make is not the GF type class, but something else that gives I'm not sure. Yeah, so I think I've been using the GEDTs for this because it's always the same type. But,
okay. Let's import the PGF file, right?
Yeah, we can start by we can linearize just the word organization, for instance. That's something we could do. So we just want to put that together. So
read PGF of,
and that's the compl.pgf, wherever we put it. Capital L.
we should do this a little bit differently.
Then right, so you can just basically I think we can do the smallest thing. You can just have it print out so if you call GF on G organization, that will be an expression, and then you can print it out, linearize it with the my PGF. So let's look at the API to find the right.
Okay. Let's just do this then. Party to GF of organization. You think this is a good approach, or should I do it differently?
Yeah, I mean, this is perfect. I think this is just fine.
Okay.
If you use the GEDT, then you can have a easier time to make a fancy type class because they're all the same type.
Okay, well, let's shall we all do gadgets today?
I mean, this is such a simple thing, and we can just keep it simple, maybe.
Okay, let's keep it simple then, just so we don't lose anyone who's okay, so let's just linearize party as a start.
Yeah.
So we've got my PGF. I've grabbed this out of the file. And then what's next? Do I need to say we're doing this in English?
Yeah. So you can, if you copy the languages to the PGF, then you get a list, and you can get the head of that list. Yes.
Okay.
Oh yeah, and the tree is the same as expr. It's just a synonym. So now what you can do is like, so put strlen, or you can make it also like let whatever let mylin equal linearize my pgf my eng. Yeah, just I'll spell it out for you. So just you can do it. You can open the. So linearize.
One sec.
Yeah. Oh, it's with the Z. Linearize with the Z. Yes, my PGF. Yeah, that works too. My PGF, my eng, and then you can put in parentheses like put parentheses and in parentheses party to GF party organization. Oh, yeah, it has to be capital O because otherwise it's like in organization. Yeah.
Okay. That's a tree?
Yeah, because tree is the same as extra. It's just
Oh,
a synonym.
right, okay.
Yeah. Okay.
Like that?
Yeah, actually,
Do you think I need to show it?
it's already a string.
Okay.
You don't need to put show. It's just, yeah.
Okay, let's see if it works.
Yeah.
Did it work? It worked. Okay, it produced output. Amazing. Okay, so what we've done here is we've read the PGF, we've run this party to GF function to produce a GF, and then we've linearized it, and then we're putting that as the output. That's cool. Okay, well, now let's just do the rest of the sentence, and then we're basically done. Does that make sense to everybody? We're like slowly and painfully welding together the Haskell and the GF, and we're producing natural language this way. But it's not that painful. It's just a few lines of code. So let's see if we can do the same thing for the rest of the sentence.
Yeah.
Okay. So if we wanted to say under certain conditions, all right, help me out. How should I do this?
Yeah. So you can start from all the atoms, like, make one for like, yeah, like you can, yeah, make one for like everything, like event.
Should I just do that as a sort of?
Yeah, makes sense. Yeah.
Okay.
You have
What I'm
you
gonna
have
do
two
is-
typos there, like CID, D has to be lowercase, and then X is like not in event to GF, and then you have string instead of X. Yeah.
Okay, so what if I were to say upon string?
Oh,
that-
no. I mean, you can't. I mean, the identifiers can't contain spaces, and
Right, so how would I say upon a certain event?
you
Upon-
can put the pattern match on the left hand side if you want.
Okay,
Like, I mean, I can also, if you want, I can add a constructor that is called upon, and it takes, I don't know, something as an argument, or
yeah, can you try that? Would this work? Or
Yeah,
so
I mean, if I add, I mean, right now, like the only event is no. Yeah, exactly. Yeah, that would work. That would work if so shall I add upon?
yeah, this way we can say,
Okay,
sunrise, sunset, liquidity event.
okay, sure. Let me add that, yeah. Oh yeah, by the way, for the party, I think you want it to, so instead of, so this is like, this party is now actually of type kind, but we want it to be of type item. Because I mean, the GF grammar is just a glorified foods, so it has kind and item. But like,
Okay, so
you can make, so on GF, like between GF and G organization, apply, like, yeah, put like dollar, and then what is it called? G the SG kind, that function there, yeah. Just apply that to G organization.
again, G what kind?
I mean, the singular kind. Yeah, exactly there. Because we want to, guess if that is going to be, if that's going to be a subject of something, then it has to be an item instead of a kind.
Okay, so that's how that becomes that, right?
Yeah.
Okay, let's see if that.
But the GPDPC is already an item, so like you might want to pattern match also the string PDPC and apply it to GF. And then that's just GPDPC. Yeah. Perfect. Okay, so let's get upon also.
So we're waiting for upon. We'll do some of the other things as well. So let's do, we've got party, we need to do condition.
do you want a quick result that is ungrammatical, or shall I take my time and make it be grammatical?
Let's start with the ungrammatical version first.
Okay,
So
yeah.
that for pedagogical purposes, we can more easily see how to go from like
Yeah.
imperfect to perfect. I
Okay.
think that would be more educational. So I'm trying to do action to GF. Does
Mm.
anyone have advice for me on how to create these G actions?
Yes, so we have name and params, so you can pattern match. If the params are empty, then you should be using the constructor called GUs.
Okay. So
make
let's
sure.
see. Constructor is GUs.
And then, yeah, so do you have it? Yeah.
Something like that.
Yeah, except that then the name has to also be like, you have to make that into pred1. That's how I call. Actually, I can remove that layer. It's kind of unnecessary.
I can add a pred1. This is how I do it.
Yeah. Yeah, so it's kind of redundant because it's just you never use pred1 in any other thing. You can just make it into action directly.
I see.
Okay, you can continue. You can start from the G compile instead. I'll change that also in the grammar so it's easier for you.
Okay. Let's see how we get to this sentence.
I think we can do two list and then arrow to the right. And then the list.
So it has to be done as a sort of test thing.
No, I haven't taken those. Or the code.
Totally forget the syntax. Action name map to list. Oh yeah, I was wondering what that syntax was. How do I do that? Okay, let me type that in. Arrow.
Yeah, that was what I meant.
Okay, cool.
It's probably not efficient.
Is that like default Haskell syntax or do I need an extension? What's it called? View patterns. Okay.
Okay, you can pull the latest.
I knew I was missing something there. View patterns and then equals something, something, something. Right? Cool, thank you. I need to shove view patterns on top, but my LSP doesn't seem to have loaded, so it's not helping me do that. Never mind, I will do a pull. Getting confused. Okay, cool, view patterns. What about empty?
Well, actually, we can do one more thing to make this a bit easier, like this, the MKCID blah blah.
Yeah.
There is a flag when you compile, when you do the gf-make blah blah blah. So it doesn't put the G, so it just keeps the names as they are. So can you just like do gf dash help?
I need to be in the day 6 now, right? Because we've
Yeah.
got grammars in there.
Can you just like gf dash help? So go up a bit. Oh, oh no, I can't see a thing.
It's one of these.
Yeah, so okay, so then there's a Haskell equals option, like just scroll up like 3 lines.
Okay.
Yeah, there, Haskell option. So turn on an optional feature, so it's no prefix.
No prefix.
Yeah. Yes, so F Haskell and then dash Haskell, no prefix. Yes. So now they are not called anymore G organization, but it's just organization. I think you need to update this. No. Did it go to the right directory? Okay.
In the right place. In the right place, yeah.
It did go to SRC. Like I think you're in. Yeah, it went here. Can you put them into SRC instead? Yeah. Yeah,
Okay.
so now we can do, we just need a show instance. But Andreas, do they have show instances? Yeah, okay, but I mean, no, it doesn't matter. Yeah, sure, because we're pattern matching strings for doing on the other side. So yeah, that's perfect. Because now we can use the MK app, MKCID. So in party to GF, go like just on, so the only special case is now PDPC, and the rest you're just gonna, so the rest you will do, let's see, we need to apply the SG kind to the thing. And
SG kind.
yeah, so like on the,
Yeah.
okay, so the whole thing should start with like GF dollar the SG kind, and no G, remove the G, because now it's just called the
No
SG
G.
kind. Because remove the G. And then I think we need to call FG to the MK app thing. So yeah, exactly. Yeah, and now you can remove the first line. It's like PDPC is the only exception because that's directly an item, but the rest are kinds that will become items by applying these functions.
Okay,
Yep.
cool.
And now I've also simplified action, so you don't need to, you don't, if the action params is empty, then we can
so
just
hang on, I need to update some of my types because they're clashing.
Oh yeah, that's true. Mhm.
To take out all the G's, right?
Oh yeah.
All right.
Oh yeah, so now the use doesn't exist anymore, so we can just do, like, we can do here the MK app blah blah blah. So like just
With, do I use the?
no, that's, I mean, that's just for fine. So just that, yeah.
Name. Yeah.
Yeah, like that. Oh, actually, no, I think actually there is, yeah, that's fine, yeah.
Okay, I need to turn on view patterns.
Mhm.
My LSP is not happy because I need to rebuild it. Okay, how do I rebuild the thing? There's a little UI. No, I've done this before. Where should I want? 8.10.4, right?
Man, your tea is probably very cold.
Oh, it's meant to be a cold tea. Yeah,
Oh,
that's
okay.
why it's doing a cold brew.
Oh, okay, it looks very fancy.
Its inos are green. Okay, hopefully this will get my thing working. Okay, so where are we here? We need to get view patterns going.
Okay, well, if we're waiting, I'm just gonna fix the grammar so it's actually grammatical.
Okay. View patterns. How do I do this? Do. Language extension. Ah. How do I do the thingy with the thingy THC options? Thank you. I always forget the syntax for this. There it is. Almost there. When is it language and when is it options? Okay. Cool, thank you. Let's try that again. Okay, we just have to fix a few other things and this should be working. Sorry, everybody, this is just like the grinding part of language engineering, but once we get this working, it will be very nice. We just need to like methodically fix all these bugs. And it'll be fine.
Yeah. So we have 80 minutes left before the next talk. So
yes.
Yeah.
We will finish in half an hour and then take a break before the next talk.
Yeah.
I think we can get there. Everybody tell me what I need to do.
Yeah, so it's the same thing like the event, because that's the now and event are again, they are imported from the comp law. So
Okay.
I mean the names of like if you go event, like there is now an event in the GF corner as well.
Cool.
So you need to like
Kind.
yeah, you can do import qualified. Yeah.
How do I make it kind?
Oh, I mean, it doesn't matter because like it's oh yeah, I think actually you need to call FG before everything, like yeah. So okay, so upon dollar parentheses, yeah, and then FG to that.
So FG this.
Yeah, that's right. Yeah. So you just need to kind of do that to all of it. But I mean, like also go up and import comp law qualified.
Import comp law.
Import qualified comp law, because there are a lot of name mismatches.
Oh yeah.
Alternatively, you can rename your event, but I mean, like, yeah.
Oh right.
But I mean, whatever. I mean, it doesn't matter.
It might be easier to rename my events.
Okay.
So I'm going to rename my event to L4 events.
Mm.
I need to rename any of these other things. Action. Yeah, I need to rename action. L for action.
Now there's a typo, L for action.
Ah, thank you. Okay. All right, what's next? I need to match the map empty. I need to just keep testing all these things. Action is now L4 action. Action, L4 events. Okay, not happy about deadline. Do we both have deadline? Deadline, let's change deadline to L4 deadline. For now, then. Okay, we're down to deontic. You have a deontic? Yes, you have a deontic. So I'm going to copy that, change it to deontic. One last thing, map empty. Okay, this is a view patterns kind of thing. How do I fix this? I have no idea how view patterns works. Is this right?
Mm. Oh, so is that your right? Okay, yeah, makes sense. Yes.
Okay, well, this is not right. Okay, how do I test for a map empty here?
That's for what?
Hmm?
Okay.
How do I put in a map empty here? Well, just error. Yeah.
It doesn't work.
I'd be very surprised if it did work.
All right. This function, the test for and not the function. Great. Oh, yeah. Yeah, it should work. No, it should work if you just write it like that.
Really? Okay.
Error.
Qualified name and binding position.
Oh. I see. Right. Yeah, right. I guess you would have to use card
Really?
or the view pattern you have inside below. You can write map.no arrow through.
Okay, well, you know what? This line actually does that. So that's fine. Okay. We're so close. Condition. Do you have condition? You don't have condition. What am I doing? Condition string has two arguments. String and list of strings. When string. Okay, let's ignore all of that for now. Then we'll have a when condition to GF when. Okay, so let's fix condition. So is there a syntax for conditions? Oh, right. Is there a sort of under these conditions, this is the state? No? Okay, well, we can take out conditions. We're so close. This is basically, you know, most of the language for a very simple timed automaton. And then once we have this language working, we can push it into GF, but then we can also push it into like UPAL. Yeah. And then we can do a lot of interesting modeling with it.
So it's been working with this level translation from the automaton to
Okay, awesome. So if we figure out the input function for UPAL, we can connect this to that. Okay, conditions. Do we have a syntax for conditions? In the chat, looking at the chat, thank you. Map null is true, yes. That would make sense. Sometimes when I run hlint is very upset about using null. I wonder if that's, I usually just ignore it. Oh, hey, it works. Okay, so our syntax with conditions. What should I do with conditions? Anyone?
Oh, I didn't add actually. I didn't add that. I only have events and deadlines.
Okay, well, why don't we just take out conditions for
Yeah,
now
let's do that. Yeah.
and see how
It's
we
complex
do
enough.
with just events. Okay, so we're going to get rid of that. And now we've got a different error. Hold on. So sentence. Okay, cool. It compiled.
It's called grammar, not grammars.
Where's my grammars?
It's grammar in singular. I just pushed.
You've pushed.
Yeah.
Okay. I will do a pull.
Okay. So where are we now? What's it? We need to go to the SRC directory. Yeah. So it's no
Okay.
new abstraction, like it's just like better grammar.
Okay. So close.
Do you know, Andreas? Is there like
Oh,
some?
I'm in the wrong, it happened in the wrong directory. My bad.
Right.
Okay, cool. Now we've got the organization. Isn't that amazing? Okay,
Yeah.
we should now be in a position to do almost everything we need for the sentence.
Okay.
So how do we do this?
Yeah.
Do an entire sentence to GF.
Yeah.
What is the output type of this thing?
Oh, expr.
Okay.
Yeah.
Sentence to GF. L for S. Parties. One tick. Actions.
Deadline.
Deadline.
Okay. So cool. Now we need let's look at the GFF syntax. I'm gonna paste something in the chat.
Okay, cool.
So like basically this is not a tree for that, but
Yeah,
like
yeah.
so it's you can always start with like sprop.
The example S prop.
So also like you need to start with like the function GF dollar, and then you build it with like these Haskell type data types.
Okay.
So then you put the first thing the first argument is the event. So yes, exactly. Yeah, and then you need to call pred and then do party to GF. Oh yeah,
Here
this is a type error now because it's parties. Can you just pattern match and take the first from the party?
Okay.
I mean, just to make this work for now, because like we don't
Sure,
have
sure.
like forever. Yeah.
Okay.
Perfect. And this next, oh yeah, you can also call the modal action. So like, yeah, open parentheses, modal action. And now then you need to call the deontic GF. Oh, actually, oh, this is actually much better. Like you don't need to, you don't need to actually call GF in all of these separately. So whenever in your blank to GF, you call GF, remove the GF. Because we're just going to call GF once here. But like, yeah, for FG, you keep the FG because that's important. Keep FG, but remove all GF. Okay?
Okay.
Go back to where we were. And
Make
then
assessments.
we have, yeah, then we have the action. So now you call action to GF. Oh yeah, actually you need to, in action to GF, you need to call FG on both cases. Yeah.
Is it okay with multiple actions or a single action?
No.
It's okay. It's a single action. That's fine. Okay, that's fine. That's fine.
Yeah, I mean we can always call, it's like, yeah, if it's an empty list, then, no, if it's a singleton,
Yeah.
then so yeah, just just do one.
Okay.
Just do one.
And the last thing that I'm missing is the deadline to GF, right?
Yeah.
So I haven't done that. Equals.
That's just called now.
Sorry.
It's just called now with capital N.
Yeah.
Yeah.
Okay, let's try that.
Yeah. You can call as soon as prac because that's the only two deadline.
As soon as.
Yeah, like that. That's what I call it.
Okay. Okay, cool.
I mean, I also have now there, but yeah, whichever. Yeah, and so we need to change the acts. So like, just do the same, like kind of match on the.
Yeah. No, it's a map in this case, so it's actually fine.
Right. Okay.
I think that will be okay. Let's try
Okay.
it. Okay, we're almost here.
What's the error?
Okay, so the error here is couldn't match deadline to proposition with.
Oh yeah, that doesn't work anymore. Like yeah, that's expected because we removed the GF.
Oh, the pred is in the wrong place. Sorry.
So like we're not even calling this sentence a GF. So.
Is that right? So do I need
the error about party to GF? That's completely expected. So it's like I mean, it's about the call to party to GF in some func, not in sentence to GF.
Okay, so
that's fine. That's fine there. Don't change anything, but go to some func and remove that thing. Like remove the whole party to GF, blah 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 blah. Like I mean, that's wrong now. It's not gonna work. So let's call instead sentence to GF my sentence one. Yeah.
Oh my God.
Ooh.
And it blew up. Who says Haskell doesn't have runtime errors?
Yeah.
Okay.
I mean, this is the downside because, like, I mean, I mean, this is not how I usually do it. It's
Okay.
like I usually make these like I usually don't do it by calling these mk app blah blah. Like I do very careful. Like, oh, there is actually another very useful flag I could have shown you because yeah, because like okay, let's see where does the error come from. So let's look at the error again.
Find eFund notification.
Yeah. So because what we can do instead of doing the like all this mk app blah, let's use the flag lexical. So if you go to a command line and do yeah, go to command line and do gf-help. And go to the Haskell options again. So here we say lexical. That lexical equals blah, blah, blah. So treat cat as a lexical category.
Okay.
I think we should treat all the kinds as lexical category. So when, like, you have the command that you've done. So say lexical equals kind.
Lexical equals kind.
Kind.
Yeah.
Oh yeah, actually you can probably call, you can say, I think actually, yeah, you can do it. Like you can say, that's gonna be easier. Say kind, comma, event, comma, like all of them except kind, event, deadline.
Which,
What
so
else do we have?
my deadline or your deadline?
Modal. Yeah, let's start with these. Like, let's start with this. So that's one thing. Okay. And now look at the complo HS file that has changed. Down. No, yeah, look at deadline, for instance. No, that hasn't changed. This is old. Yeah, this is old. All of this is old.
Right directory. Is that what I'm looking at? Is this correct?
I mean, when the categories are lexical, they have a new constructor that just takes a string. So instead of having a constructor for data breach, data leak, organization sunrise, we just have lex kind, which takes any string. So that's very easy to map.
Isn't that coming up?
Like this doesn't. Okay. Let me look how we're. Was there something wrong how we used the flag or like?
Okay, did I get it right? Did I get it wrong here?
I mean, well, obviously there was something wrong because the file hasn't changed. So I'm gonna just look from the baby L4 how we're doing it there because we're using that flag there.
Okay. So close.
Oh, okay. Yes, you need this. Let me paste. So in the command that generated the files, you have Haskell no prefix, Haskell lexical, and then lexical. So like between those, like.
Haskell equals no prefix, so change that to lexical.
Yeah, I mean, no, replace. I mean, not really add. So between those, so just space dash dash.
Space.
Like another flag. Haskell equals lexical. Okay. Yes, and now that's it. Okay, now look at the file. Should have changed. Yes, look at kind. Lex kind string. Lex modal string. So now we don't need to do the MK apps anymore.
Okay, cool.
So now go to a lib on all of the places where you have MK app, blah, blah. So, and like, now you can, so everything that says like, so you don't need to do the FG either. It's just upon, and then like upon lex kind string. Oh, yeah, and like, yeah. Yes.
Like that?
Yeah. Yes, lex kind X. Yeah. The action, unfortunately. Oh yeah, if it's empty, then you can just do. Yeah. Oh yeah, we didn't do that. Sorry. So let's see if that works.
Almost there.
Yeah, because there are like different constructors for action, so I couldn't do that.
So Lex may and Lex as well change.
Yes. Yeah. If you don't want to change that, then you can just like return with the file without having modal as Lex. Actually, that makes sense.
So hang on, the modals have just turned into strings, right?
Yeah, but I mean, you can revert that. If maybe that doesn't, maybe that actually makes sense. So if you like, yeah. I don't know. It has to be capital. I mean, that's because the GF
Okay,
is.
it's still in there. Okay. And what else? Action.
Yeah, like action hasn't changed because we have different constructors. I can't make it.
As soon as.
Yeah, that's also lexical. You can make that because we have now and as soon as prac, so you can just make that into now. And wait, it has to be Lex deadline, not Lex kind.
Oh, sorry.
They are flipped. Yeah, okay.
Cool.
Okay, let's try again. Yeah, okay, that's because it's, can you just make it capital M? Let's make assessment in capital M. And can you change also notification to sunrise with capital S? Yes.
Yeah. It's very cool.
Yeah, and you can make this then whatever. So yeah. Yeah.
So if I wanted sunrise to just come out of a string, here it's coded as a.
Because upon takes a kind, so it is actually like it's already like upon is a constructor, but then it takes Lex kind the string sunrise.
Okay, cool.
So,
All right, well, brilliant. So I'm going to check this in.
yeah.
Because it's working. And I'll check that in, and I'll check that in.
Well, that was, now we have like 10 minutes before
Yeah.
the next talk.
Shall we stop here, take a break, take questions, discuss? So I think just to sum up on where we are, I would like to observe that we have kind of met our goal for the day. Today's goal was to build an application grammar in GF, integrating PGF with a very simple Haskell type system representing the core semantics of laws and contracts with a simple embedded DSL. And that has potential for an external concrete syntax via a compiler frontend. So it's done. Yay. Thanks, everybody.
Yay.
Good. Any final thoughts, or shall we go take a break before the next session? Short break, 3:30?
Yeah.
Okay. Thanks, everybody who's been patiently listening to this on the recording or on Zoom.
Yeah, we have some people in the, like we have some external people on Zoom. Even.
Okay, cool. Still grinding.
Yeah.
Hey,
Yeah.
if you've lasted this long, you should apply for a job here.
Oh, yeah. Okay.
And now I'll have a cup of tea.
Yeah. Can I taste your fancy tea, man? Okay, maybe I'll stop this stream and then we can take a new stream for Krasimir's talk. Hi, Krasimir. You're just in time. We just stopped our talk and we're having a break here. Yeah.
Yeah. I just joined earlier to be sure that I